bit about how to use Spotfire for running machine learning models, namely supervised and unsupervised models. The template I will be showing, the Spotfire instance, can be downloaded from the community site. So we're here at community.tibco.com. If you go to Exchange, at the top you can choose the product you want to see the exchange options about. And the template that I'll be showing is the Financial Crime Buster Analysis template for Tibco Spotfire, available right here, and it's fully documented there. So let's go into business. This is the first sheet of the template, and it starts with an introductory page that explains the structure. Basically, there are 4 parts. In the first part, which corresponds from this to this tag, you have some options and some suggestions of how to visualize and understand your data so as to answer the use case for financial fraud. Importantly, however, and we will see that later today, we can use the template for other use cases as well, because mathematics is mathematics and will adapt to the numbers we give it. In the second part, we will look at then how to make supervised learning models. In part 3, we will see how we can do unsupervised learning models, and in part 4, we will show how to apply both those models to your current data set, either in batch or via stream-based to real-time deployment. The information we'll share, and this template has been based on a white paper that has been published on the Tibco community site and on the Tibco site as well, and is available inside the template. So in part 1, the first page, Add Your Data, allows you explains how you can replace the data set in this template with your own, and we will show an example of this in a moment towards the end. Then the first page, the following page, Initial Exploration, allows you to select your categorical variables and your numerical variables and just look at it from a descriptive statistics point of view. And here you can use this for example, cleaning problems in your data. If you have some misspelling of some categories, you can just right-click and group those categories, for example, together into a new category if there's some misspelling somewhere, and other cleansing and improve results to data. In the next page, we're already searching for fraud indicators. So finding fraud in your data is like finding the KPIs on which you can find a few number of people that have unusual behavior. And all this is explained on this part, on these instructions here. So basically, you want to find for unusual in behavior, not just in people, but in transactions themselves, or in any level of aggregation of your intervenience. So you could, for example, want to see it by department, or by store department, or by groups of employees or teams, or, for example, by branch. So the level of granularity that you'll do your analysis at is what you put in the x-axis. Here we have row number. And in the y-axis, you can use your creativity and your knowledge of your business to put in KPIs that reflect where you believe, as a hypothesis, and are not sure of it yet, there might be traces of fraud in your data given your current setup. And this is often a very personal moment, because the right KPIs change from company to company, and never believe otherwise. So in this case, we can see that there's a very small number of people who have an unusually high number of average transactions from the same card in the last 24 hours. Now, if you zoom down to the bottom part of the chart, you can see that most people actually have really close to 0 number of average transactions. The numbers are normalized. So who are these people who have such unusual behavior? And so we can just select them and see them below to have an idea of whether our KPIs are demonstrating and denouncing a fraud when you actually look at the data, or maybe are talking about some other reality. So really, in part 1, you're using Spotfire visual analytics tools to increase your ad hoc data discovery and your understanding of your data. In the next sheet, if your data, historically, if you're analyzing your transactions, you have seen which are fraud and which aren't. you can use that information to feed your further model. So, for example, when we here choose which variable contains the identification of which lines in your data are of one type or the other. At the bottom, you can choose the categorical variables you want to do your analysis by, or the numerical variables here. And these drop-downs automatically reflect detect the type of category or variable you're looking at. So, for example, here, if you choose payment, we can see that when people pay by credit card or PayPal, historically we haven't seen much fraud, but when people pay by store credit, that is where often historically there have been issues, which suggests, because there is such a big difference between the behavior of these different categories, that it is important to consider this feature in your future models in the following sections. Down here as well, we have that the box plot, which is a representation of the distribution of this variable value, shows that there is, when fraud is 1, so for past fraud transactions, we have tended to see higher values in transactions. And in fact, the fact that there's 2 dots here shows that one of them stands for 0 and for 1, and it shows that the 2 groups are statistically significantly differentiable, which means this is a good variable. So now, after we've been playing with our data and increased our understanding of how fraud leaves a mark in our data and where, we can go to part 2 to learn how to detect, use the known fraud cases in our model. So here we're going to use a supervised learning algorithm, where supervised learning is a set of algorithms of machine learning that specialize in giving you the best way of finding the answer you want to predict. And the answer in this case is contained in the column that says historically which lines were fraud and which were not. So in the model building section, here is my fraud variable. I am representing with 1 the frauds and 0 otherwise. And here I can choose the values, the KPIs that I'm going to use as in my model. These are set by Spotfire, the document property that receives all the columns that are in your data table automatically. So when you change your data table, this refreshes. So when I press the button now, the Spotfire will call out to TARE, which is Tibco Enterprise Runtime for R, which is R motor that was created by Tibco that's faster and more robust than R, and it is just embedded in the product in Spotfire when you use the analyst. Spotfire will pass the choices the user has made onto TARE, who will apply the model called random forest to the data and gives us a set of results. Now, random forest is a type of model that I particularly like because it doesn't require any a priori assumptions regarding the data. Therefore, unlike, for example, regression or logistic regression, therefore, whatever results your model gives are pretty safe to be used by a business user, even if he's not that knowledgeable in statistics. He's not that knowledgeable in statistics and math, but he knows these KPIs very well. And that is often, for me, not just good models make good results, also strong KPIs are sometimes the best drivers to getting a good machine learning model, and business authors and business users are often the masters in KPIs. So the result of our model tells us in this first page that historically in our data, the best predictors for fraud have been the number of transactions done by from the same card, device, or account in the last 24 hours. And this is where, therefore, it has been proven mathematically that that's where fraud has been leaving its mark historically. And for example, if you look at, for example, whether the purchase was a gift or it was paid by credit, has historically been seen as not being relevant at all. So this increases our culture about the data and can even help us identify aspects of our internal control procedure that should be improved in order to keep this type of fraud from recurring. In the next sheet, in the model assessment part, we provide plenty of visuals that you can just focus on the first one to give us an idea of the quality of the model. So basically, when we run our model by pressing that button, we will separate 20% of our data, and that the amount of data can be an option, of course, and use that not for training, so for testing, which ensures that the quality evaluation that I make of the model is impartial. Of course, the sample is randomly selected. So, and I have included that as part of my script that ran the random forest model. So this view here shows me that this is the curve that represents the quality of the model. The closer it is to the green line, the better. The closer it is to the red, the worse. And this is all a business user needs to know in order to evaluate the quality of the model, basically. In the x-axis, we have the fraction of the population that has to be investigated manually, which in this case is 10%. And if we choose that to be 10%, we will be able to, using this model, take 96% of all existing fraud, which is pretty good. So in the next page, we can now apply our model to our existing set of transactions, or to a set of, the set of transactions that we left for testing, and we can now use this as a way of choosing a threshold for when we spot a new transaction that has a probability of being like past fraud, as measured by the random forest model my business user has just created from this dashboard that speaks business language. I can now decide which threshold to use, and for example, I know that if I use an 80% threshold for separating in manually investigating operations, I will get 16% false positives, which means 84% true positives. And I hear that in the business, normally proportions of true to false positives tend to be 50%. So now I can use this threshold I've written here and leave it stored for future reference. Let's move on then to part 3, where we have the unsupervised learning part. The unsupervised learning is very important for fraud because fraud just change all the time. It's a very changing reality, and maybe the next fraud idea will encompass an area that is completely unseen in the past. Therefore, it is important to use a model that is not just searching for the past answer, but also allows you to have surprises and spot odd things in your data. So in this first sheet, we use a factor, we create some factors from the data. So when you press this button, we call out to tear again. In this case, our data is in memory, and so we're using the in-memory tear. But if our data had been big data in a Hadoop cluster, we could press a button like this to run a model in the cluster, locally in the cluster in Hadoop, and report the results back to us. It's important to say that the look and feel of Spotfire is consistent for modeling and visualization in big or small data. So now, the advantage of this type of analysis is that it puts close to the origin of the chart what is considered to be the normal average transaction, like all the rest, and very normal in our organization, and then puts far from the center a metric of how unusual the transaction is. So when I measure the distance between any point and the center, I have a measure of how odd the transaction is, which I can then use as a measure of risk of that transaction. And notice that I've done this without starting by the answer of past cases. It's just by looking at odds. So now, this is an optional page that allows you to, instead of measuring the distance between a point and the center, considering if there are different clusters of data, then using that information for defining oddity. And everything, like I said, is explained on the side of the instructions. So now, this is the measure of oddity as applied to all my data, and I can choose a threshold here that tells me how likely I am to be above. What is the true or false positive ratio if I choose this threshold? Notice that the true or positive ratio here is not a name for us, it's just a guideline, because in fact, the true positives may have been things that, not that were not fraud, but that were not spotted by past rules. So we actually do want to look at them anyway. Finally, in part 4, we can take those two models and apply them to our set of existing transactions. And so we score each transaction by the probability of being like past fraud and by oddity, and some of them will be caught by just the oddity threshold, others by just like past cross threshold, and then other by both. Alternatively, if I want to deploy my model to real time, the business user himself can press a button and send not just the supervised model, but the threshold and information that can be used for treating meeting values on the run, as well as the unsupervised model to Streambase, which is our engine for real-time processing. So I will show very briefly, what Streambase looks like. So this is Streambase. Streambase is a real-time processing engine that the end user never ever sees, but just sits in the background and elegantly receives the model that was loaded from Spotfire. The models were TER models. TER, like I said, is integrated in Spotfire and is also integrated in Streambase. So without stopping current transactions, Streambase notices there's a new model, loads it, and then uses it for processing new transactions. You can visualize all existing transactions and how they are being scored in real time, and then you can separate the dodgy transactions, so those that violate the thresholds the business user set from Spotfire, and these will be, we will create a business process management case, which is our case management tool, that will be sent to investigators as a tool for them to investigate and maintain the auditability record of every transaction. Notice that we've been talking about fraud, but a similar setup of creating a model in Spotfire and then launching it in real time can be used for example, identifying which customers are likely to churn and sending in them offers in real time from your website, or making offers for cross-sell campaigns. So I had paused the Streambase flow, so I'm going to resume it, and we can come and see how LiveView is doing. Sorry for that. So this is LiveView. And LiveView, like I said, is an engine for visualization of things in real time. We always have to refresh it when we're starting. Oh, I must have pressed the wrong button at a point. Sorry for that. Resume. And now we see, there you go. Lovely thing on a webinar. So here we have our transactions happening in real time, with the threshold being seen in orange and the points being seen in blue. So that's the threshold, and we've had several transactions go over the threshold. For each one of them, we have received an email alert with the context of all the transactions, as well as the case management case that we can accompany. Moving back into Spotfire, I would like now to quickly demonstrate how we can apply this very same threshold to a completely new set of data. So if I go to this template, add your data, it explains that I can, has indications of how I can replace data. So if I go to File, Replace Data Table, I can replace the fraud input data with a new data set that I will select from a file, which is this one. This is a data set used for customer churn. And so I'll just say, okay, Spotfire immediately understood the metadata of the data. It says that the names do not really match, which is fine because it's an entirely different data set. It warns me that some visualizations may have changed. So now I can start my initial exploration. Here, automatically Spotfire picks the categorical variables, and here the numerical variables. So I can see if they're clean and there's any errors there. Here I can pick any other variable again of behavior. So say, let's take a numerical variable, for example, the charge over 3 months. So there's a good example of a potential good variable for fraud. Here I have to say which customer contains the variable I want to predict, which is called customer status, and lines are identified with the line churn. Now I choose a categorical variable at the top and a numerical variable at the bottom, and I see how my data behaves. In the model building part, here I already have the names of the new columns, so I can refresh the model and see the respective results. If I, by the way, I want to create a new column, I said that often finding the best KPIs is a matter of, the best model is a matter of having the best KPIs. So I can just add a new column in insert calculated column and do if, so coming to my data table, if gender equals F, then once else 0, and call this gender, and my new column appears automatically there. So that's the result of my model. I won't go through the interpretation again, but I can also do the same for picking the right variables and doing customer clustering by applying the unsupervised learning. So that's what I had to say. So I hope you enjoyed the session, and I'm moving on to Andrew, making him present for him to continue with his presentation. Thank you very much.